Imagine a race where the fastest runner can never catch a slow-moving tortoise. Over 2,500 years ago, Zeno of Elea used this paradox to challenge our understanding of motion and reality. These puzzles of infinity have shaped mathematics, physics, and philosophy from Aristotle to Newton to Russell. Is motion real or an illusion? Is reality continuous or built from countless frozen moments? This is the story of how a Greek paradox reshaped how we see the universe. Zeno of Elea was a Greek philosopher of the Eleatic school and student of Parmenides, who taught that all reality is one and unchanging, that motion and change are illusions. To defend this view, Zeno created about 40 paradoxes as logical traps showing that believing in motion or plurality leads to contradictions. His motion puzzles exposed contradictions in moving from point A to B, problems unsolved for millennia. Zeno's Achilles and the tortoise paradox imagines a race where the fast Achilles gives a slow tortoise a head start, say 10 meters. Achilles runs 10 times faster, so by the time he reaches the tortoise's starting point, the tortoise has moved 1 meter ahead. Mathematically, the total distance Achilles runs forms an infinite geometric series, 10 plus 1 plus 0.1 plus 0.01 plus. Zeno saw this as endless, implying Achilles never overtakes. Modern math, however, shows that such a series converges here to 11.111 meters, meaning Achilles does catch up after a finite distance and time. But for Zeno, this infinite sequence revealed a deep paradox. How can motion be real if it requires completing infinitely many tasks in a finite span? Zeno's Dichotomy Paradox argues that motion is impossible because any distance can be divided infinitely. Before reaching a destination, one must first go halfway, then half of the remainder, a quarter, an eighth, a 16th, and so on ad infinitum. The runner, like Atalanta in Aristotle's version, must complete infinitely many steps even in a short race. Mathematically, the distance forms an infinite geometric series. An half plus 1/4 plus weighty plus 1/16 plus equals 1. Modern math shows this series converges to a finite result, but to Zeno, the idea of summing infinitely many parts to reach a finite goal was absurd. This paradox differs from Achilles in focus space instead of time, but both reveal the same tension. If a journey can always be subdivided, how can motion ever begin or end? Zeno's arrow paradox questions whether motion can exist if time is made of indivisible instants. Imagine an arrow mid-flight. At any single instant of frozen now, the arrow simply occupies one position. It's not moving to where it is, already there, nor to where it isn't, no time to move. If this is true for every instant, then at every moment the arrow is motionless, so how can it ever move? Zeno concludes that the flying arrow is at rest, since time appears as a chain of still moments. Motion then becomes an illusion, much like a film reel, a rapid sequence of still frames that our eyes interpret as continuous motion. Mathematically, if we treat time as discrete points t1, t2, t3, position, xt, changes between them but never within a point. Only with the later idea of continuous time and calculus does motion make sense, as a limit where instantaneous velocity v equals dx divided by dt. Zeno's stadium paradox explores relative motion and time. Imagine 3 equal rows of blocks, A stationary, B moving right, and C moving left, all moving at equal speed. When one B and one C block align with a fixed A, that's the starting point. After a short interval, the B block passes all the C blocks since they move toward each other, but only half the A blocks since A is still. In the same time span, B has covered twice the distance relative to C as it has to A, leading Zeno to claim that half a time equals the whole time a contradiction. Using distance equals speed times time, he assumed time was absolute and universal. Later, thinkers saw the flaw, motion is relative. The BC meeting speed is double the BA speed. So both effects fit normal physics once frames of reference are separated. Zeno's paradoxes sparked centuries of debate about motion, infinity, and time, leading to major breakthroughs in philosophy and mathematics. Aristotle, 4th century BC, gave the first clear response. He distinguished potential infinity from actual infinity. As a runner divides distance into halves, quarters, eighths, etc., the time also divides proportionally. And half plus 1/4 plus 1 total plus equals 1 total time. Thus, infinitely divisible motion can still occur in finite time. For the arrow, he rejected time as made of frozen instants. Time and motion are continuous, not built from static nows. Later antiquity, especially Archimedes, refined these ideas. He showed a finite line can contain infinitely many points, distinguishing between infinite extent and infinite divisibility. The true resolution came with calculus in the 17th century. Newton and Leibniz introduced infinitesimals and limits, proving that infinite series could converge to finite results. For example, in Achilles' race, if he runs 5 times faster than the tortoise, 1 plus 1 divided by 5 plus 1 divided by 25 plus equals 1, 2, 5 distance units. Calculus defined instantaneous velocity and continuous change rigorously, showing that an infinite process can yield a finite outcome, the mathematical end to Zeno's puzzles. In the 19th century, Cauchy, Weierstrass, and Dedekind rebuilt calculus on solid logic. Using epsilon-delta limits and real number theory, they eliminated vague infinitesimals and proved that motion through infinitely many points doesn't require completing infinite steps. It's a continuous function of time. Set theory later confirmed that a line segment holds infinitely many points without contradiction. Mathematically, his paradoxes are solved. Philosophically, they remain alive, asking whether space and time are truly continuous or if reality itself hides the same infinity Zeno once revealed. Thanks for watching. Don't forget to like, share, and subscribe if you want more deep dives like this.